One of the reasons that we want to be able to write complex numbers in trigonometric form is because it's going to help us simplify certain computations. Now, at first, it may seem that they look more complicated, but as you move into higher powers of complex numbers, you're going to find that the trigonometric form makes your life much easier. We're going to start with multiplication and division of complex numbers. I have the two formulas here for you. And let's just talk through those. We're talking about two complex numbers, Z1, which we're writing in trigonometric form, and Z2. So there's a lot of subscripts there, but notice that it's just designating between the two different Z values. If you wish to multiply those two complex numbers together, you can simply multiply their magnitudes. And then notice here we're dealing with our sum and difference trigonometric identities that we just discussed previously. In the multiplication, much like when you multiply exponents, you add the exponents together. So here with multiplication, we're adding our arguments together. With division, it's the similar formula, except we are subtracting our arguments. So let's look at an example here. If we want to use the product formula, so we're going to add our arguments to multiply these two complex numbers that are written in trigonometric form. We're going to have Z1 times Z2. And using our formula from above, it's going to be the magnitude of Z1, which is our 3, times the magnitude of Z2, which is 2, times the cosine of the sum of the arguments, 5 pi plus 6, plus 2 pi over 3, plus I times the sine of 5 pi over 6, plus 2 pi over 3. As we simplify that, 3 times 2 gives us 6, times the cosine of 9 pi over 6, plus I times the sine of 9 pi over 6. Notice those angles we can reduce, and we get the cosine of 3 pi over 2, plus I times the sine of 3 pi over 2, which falls on our unit circle very easily. We know that this value is going to become 0. This is going to become -1. So we end up with 6 times 0 plus -1i, or just a value of -6i. If we want to divide complex numbers, we're going to use the same general process using our quotient formula. So we were going to have Z1 divided by Z2 is going to be the magnitude of those two divided by each other. And then we're going to have the cosine of the two angles. We're looking at the cosine of 117 plus I times the sine of 117 divided by 2 times the cosine of 117, or I'm sorry, of 72, plus I times the sine of 72. And when we plug those in to our formula above, we get 6 divided by 2, which gives us 3 times the cosine of 117 minus 72, plus I times the sine of 117 minus 72, resulting in 3 cosine of 45 plus I sine of 45, which again, from our unit circle, we get 3 over the square root of 2 plus I 3 over the square root of 2. The idea of the multiplication and division can also be seen graphically. If you remember what we talked about previously in terms of multiplication and division, we're adding and subtracting the complex numbers, and we're adding and subtracting the arguments. If I take Z1, Z2, and I'm multiplying them together, but want to use Euler's formula, I'm going to get that it's the magnitude of Z1 times the magnitude of Z2, e to the I plus the arguments of each of those. And Z1 divided by Z2 is going to equal the magnitude of Z1 divided by the magnitude of Z2, e to the I theta 1 minus theta 2. So how does that apply in an example? Well, if I want to plot these two numbers and then also plot their product on the same graph, notice from the formula we just looked at that Z1 times Z2 is going to be 2 times 3 e to the I of pi over 3 plus 5 pi over 6, which becomes 6 e to the I 7 pi over 6. And if I use those magnitude and arguments to get my lengths and my angles, so here's my magnitude and my argument, my magnitude and my argument, which gives me 0.1 for Z1, magnitude of 2, argument of pi over 3. Here, magnitude of 3, argument of 5 pi over 6. And then when I multiply them together, magnitude of 6, argument of 7 pi over 6.